Uh, Going to talk about your next topic, that is about your transactional database in unit 5. Already we have seen even this in your first unit. What do you mean by generally a transaction? We have seen, like, you have rows and columns, you have entities, you have attributes, yes or no. A transaction, whenever I walk into a supermarket, I'll buy some product, I'll do a transaction there. On the transaction, what do I have? I have a serial number, I have my product, and the transaction, the amount, whatever it is, would be there on my receipt. That is nothing but the transaction. This complete details will be saved in their database. That is nothing but your transactional database. Now, here in your transactional database, we are going to see three things. One is about how sequentially it is used, how scalable it is, and how it is constant based upon your sequential patterns. When I talk about your how sequential it is, now for example, I'll tell you. Now, I am having a transaction details of a customer who is purchasing the regular items from 1st January to 1st December. Okay, complete a year. So if I break in between, that is not my sequential. Now, if I have January month transaction, February month transaction, I am skipping the other months. Again, I'm starting this transaction from October, November, December. Now, this is not my sequential transaction because the person, the customer who is coming here is buying the product from January to December. So, I need to maintain the transactions of that customer from January to December. See, as I told you, we're going to talk about your transactional database. In that, first, I'm going to talk about your sequential pattern mining. Like a sequence database consists of what? Sequences of ordered elements or events recorded with or without a concentric notation of time. As I told you, it's the same one. Now, a consumer or a customer is coming to me and purchasing the product in the supermarket. I need to record all his transactions from January to December. I can't break it. So, on a sequential ordered wise. Now, this involves customer shopping, your web click streams, your biological sequences, everything comes into picture. Now, this sequential pattern mining is mining of frequently occurring ordered events or subsequence as patterns. The same thing again. See, I'm buying the same product, the customer is buying the same product every month, so I need to have a track of it. Next, this is what it has a different patterns. Now you have a numerical curves here, you analyze it, you analyze the trend analysis, you forecast, you talk about the statistical things based upon the time series analysis. How these are all a sequential. Now a customer is, for example, the same customer example, now a customer is buying the product in January to quantity. He liked the product. He is buying 3 in the February. Next, 4 in the March. So what is happening? The analysis, the trend analysis, or I am forecasting that now in the March he has purchased 4 products. Now in April he might purchase 5 of the same product. That is nothing but your sequential pattern mining. Next, I told you about your scalable. Second is your scalable. What do you mean by scalable? You have horizontal and vertical. This is nothing but your scalable. So how do you scale it? Here we use your a priori algorithms, you use your GDPs, you use uh, your theorems, everything. Now, scalable methods for mining sequential patterns. You, as I told you, you have horizontal and vertical format. Your horizontal format is called as what? Your GSP, which adopts your candidate. It generates the candidate and the test approach using your horizontal format. Next, you have spade. Spade is what? It adopts the candidate generate and it tests using your vertical data format. As I told you, you have horizontal and vertical. Here, your horizontal is nothing but your GSP. Here, vertical is nothing but your spade. You have even prefix span, which is used for your pattern growth method. It generally does not require to generate or require a candidate generation here, but wherein when I talk about your horizontal and vertical, you require your candidate generation. Next, you use your direct and indirect approaches, and you use your a priori all the properties to get the output for it. We have to know whether it is fail and pass. So we'll just check with your a priori property. The third one is constraint based. constraint is nothing but what? It reduces whatever the search space is there. So it limits. Now, when I am searching for a product, it limits only to that product. It doesn't go on or checked with the other product. Now, I am checking out only with the rice. So, it checks only with the rice of different qualities. It doesn't go to wheat or any other thing. Now, constraint can be expressed in many forms. They may specify desired relationships between attributes, attribute values, and aggregates within the resulting patterns. The same thing, as I told you, now rice is my entity. In rice I have multiple varieties like Sona Masuri, Basmati. These are all the attributes of the rice. So it checks with the attributes and its values. Now Sona Masuri I have 25 kgs, Basmati I have only 10 kgs. Like that, it checks with the attribute values. Next, here even the regular expressions are also used to form what? Pattern templates. Then even this uses some duration, some t for checking out the maximum and minimum length of the database also. So this is all about your constraint based mining of sequential patterns. So we have seen about the transactional database. Transaction is nothing but what? You have a, basically we use a database. Here, like your rows and columns, you have entities and attributes wherein you record the transaction. For that records, we predict about the futures. That is nothing but your transaction. Here we have seen about your sequential, then your scalable, and last one is your constraint based mining. This is all about your transactional database. Thank you.